Today, we're diving into something really cool, a totally new way to customize the world's most powerful AI models. And the best part? It's a method that works even when we can't actually change how they think, even when they're locked away in a so-called black box. It's a real game changer. So let me ask you this. What if you had access to a genius who knows pretty much everything? Sounds great, right? But here's the catch. You can't teach it anything new directly. It's brilliant, but it's totally set in its ways. This is the exact problem that AI developers are facing right now. And the solution they've come up with is, well, it's surprisingly clever. First up, let's talk about this genius. We're talking about those massive frontier AI models that are powering so much of our tech. But they come with this one really frustrating problem. They basically live inside a locked box. Exactly. So when we use these incredible models, it's usually through an API. We can ask it stuff, get amazing answers back, but we can't actually peek inside and change its core programming, what are known as the model weights. You can think of it like its fundamental brain wiring. That's locked away for all sorts of reasons, from trade secrets to safety. The bottom line is we can't alter how it fundamentally thinks. This leaves us with, well, two pretty limited options. Now, the ideal way to do this would be fine-tuning. That's like performing brain surgery on our genius to give it new skills. But since we can't get inside the box, that's off the table. So what does everyone do? Prompting. This is kind of like handing our genius a single static instruction manual and just hoping it works for every single task. And as you can probably guess, that approach is often really brittle and doesn't adapt well at all. So if we can't retrain the genius, and a static manual just isn't cutting it, what's left? Well, this is where a brand new character enters our story, the coach. And that coach is the advisor model. The idea here is just brilliantly simple. Instead of trying to change the giant student model, you train a much smaller advisor model. Its only job is to give custom, personalized advice to the big model for each and every task. So yeah, it's not the genius. It's the genius's personal coach. And this is the absolute key. The advisor doesn't need to be smarter than the student. Not at all. It just needs to be a fantastic strategist. It learns from trial and error what kind of guidance helps that genius perform at its absolute peak. It's learning how to communicate, not relearning all the knowledge itself. So you might be wondering, how does this little coach get so smart? How does it figure out the perfect thing to say every time? Well, it uses this really powerful feedback loop called reinforcement learning, which, is really just a fancy way of saying it learns from trial and error with rewards. It's a really simple four-step dance. First, the advisor suggests a strategy. Second, the big student model follows that advice and spits out an answer. Third, that answer gets a score, a reward, based on how good it was. And finally, and this is the magic part, the advisor sees that score and updates its own playbook. Good advice gets reinforced, bad advice gets tossed out. And it does this over and over, constantly refining its coaching skills. Okay, the theory is pretty cool, I'll admit, but does it actually work in the real world? Let's take a look at the experiments, because honestly, the results are pretty dramatic. So the researchers set up this great little personalization challenge. An AI had to write a movie review for a user named Matei. But here's the twist. Matei had a secret preference. He only likes reviews that are super short, like 10 words long. The big question was, could the advisor figure this out without ever being told directly? And these results just show the learning process perfectly. Check this out. Before training, the advisor's advice was just way off base. It suggested a 600-word review. It completely made up this preference for detailed analysis. But after learning from feedback, bam, its advice was spot on. It correctly figured out Matei's hidden preference for short, snappy reviews. But of course, this brings up a really important question. Is this whole dynamic coaching thing really better than just spending a bunch of time crafting one perfect, static prompt? Well, the researchers put that to the test. And wow, the data really speaks for itself here. The baseline, with no special instructions, gets it right about 47% of the time. Then they used an advanced static prompt optimizer, which actually did a little worse. So neither of those could really figure out what the user wanted. But the advisor model, a whopping 95% accuracy. It didn't just improve things a little bit, it pretty much solved the entire problem. And get this, in some cases, it was literally perfect. When they tasked it with identifying a user's preferred reading level, like for a kid versus a college professor, The advisor system hit 100% accuracy. It completely nailed a challenge where other methods just fall flat on their face. But that incredible accuracy is actually only part of the story. It turns out this whole coach and student approach has some amazing side benefits that nobody really saw coming. There are 3 huge advantages here. First is transferability. A coach trained on one AI can successfully coach a totally different AI. Crazy, right? Then there's robustness. Since you aren't actually messing with the big student model, it doesn't forget its other skills, which is a common problem called catastrophic forgetting. And finally, it's super cost efficient. You can train the small advisor on a cheap, simple model and then deploy it with a super expensive, powerful one, saving a ton of money. And let's just look at the data on that robustness point. The researchers tested the student model's math skills, which it scored a 64% on by itself. When they added an advisor that was trained specifically on math styles, that score didn't budge. But what's really incredible is that even when they used an advisor trained on something completely unrelated, movie reviews, the math score barely changed. This is huge. It proves the students' core skills stay totally protected. So, the really crucial point, the big takeaway, is this. With this method, you get the absolute best of both worlds. You get a system that's highly specialized for your specific needs, but you still get to keep all the raw, general-purpose power of the original massive model. And that leaves us with a pretty fascinating thought to chew on. This research really opens the door to a future where we don't just use AI, we actually coach it. We can train these little personal advisors to make these powerful systems align perfectly with our own unique needs, or our company's voice, or just our personal style. So the question really is, if any AI can have a personal coach, what are you going to teach it first?